if you missed the beginning, we were talking about fried ice cream that you can get in some Mexican restaurants. So you might want to try it if it sounds good, or you might want to avoid it if you think it's got too many calories. Right. This is what we're going to be doing today, the dot product, and we've already touched on it before. Essentially, this formula here is one of the two common versions of the dot product. In this form, it allows you to find the angle between two vectors. And for a lot of questions, it's basically going to be plug and chug. So I'm just looking at a question randomly here. Question 3. They give us two vectors. The first one, u, is 8, 0. And the second vector, v, is 5 and 2. And they break it down for us, which is fine. Question A says, find the dot product. That's this bit. And then question B says, find the angle to the nearest degree. So we know we're working in degrees and its whole numbers. So get my calculator handy because I know I'll need it. Make sure I'm in degrees, which I am, and we're ready to rock and roll. The dot product, the x component, 8 times 5 multiplied, plus 0 times 2, that's 40, that's nothing. So the dot product is 40. It's as straightforward as that, right? X component times x component plus y component times y component. Now, if you want to get theta, we're going to use this formula. So the cosine of theta is the dot product, which we've already found, divided by the magnitude of each vector. So we're going to do that. I've got this guy up here. The magnitude of this vector is 8. And for this one, it's going to be 5 squared plus 2 squared, which is the square root of 29. How come that is 8? Is there any obvious way of telling that a vector that looks like this, why its magnitude is 8?
Because the square root of 8 squared is 8.
Right, oh, which is totally correct. Or isn't it just 8 units to the right and it doesn't move? So that means it's 8 units long. And wouldn't 0, 2 just be a magnitude of 2? I mean, it probably saves you 2 seconds, right? It's not going to save you a great deal of work. But if you see it, you can do it. If you don't, square it and do your stuff. So we're going to take 40. And it's going to be 8 times square root of 29. And that's the cosine of theta. So to get theta, you just need to find the inverse cosine of this ugly fraction. And here goes. Inverse cosine. Top number is 40 divided by, put in a bracket, 8 times square root of 29. Close a couple of brackets. That's 22 degrees to the nearest whole number. Pretty straightforward. Plug and chug. Right, you got a formula, find all the bits, plug them in, let the calculator do the thinking. And there is a bunch of questions, basically just like this one. So that's going to be, I'll take a little note up here. Question 3 is just like that one. Question 4, question 5, question 6, 7, 8, and 8. So questions 3 to 8 pretty much look like that. The only difference is that some questions, the vectors are written using this notation, and sometimes you get the vectors and they're written like this. Right, this is I-J notation. Remember, I is 1 in the X direction and J is 1 in the Y direction. I don't like that notation. Just something about that is clunky in my brain. Even if it doesn't start life off as like that, do you know, I immediately write them down like that anyway. And that way I'm doing all the questions the same way. Well, since I've kind of started this one, I guess I should complete it. 2 in that one, so it's going to get me a 2 squared plus a negative 3 squared, which is the square root of 13. The magnitude of vector v is the square root of 4 squared plus 2 squared, which is the square root of 20. Now, I might be able to simplify one or both of those square roots, but I'm not even going to bother. And the reason I'm not going to bother is, aren't these just going to be plugged into a calculator later? So there's no real great advantage, right? Now I need a dot product. And it's going to be 2 times 4 plus negative 3 times 2. And that guy is 8, and that guy is 6, and so the answer is 2. Okay, I've got all the bits. I need that bit, I need that bit, and I need that one. So the dot product says the cosine of the angle is the dot product divided by the 2 magnitudes. So this is going to be 2 over the square root of 13 times the square root of 20. And so the inverse cosine of that, and we're done. On the calculator, inverse cosine, 2 divided by, put an extra bracket around for the bottom 2 guys, square root of 13 times the square root of 20. A couple enters, it's about 83 degrees. Are we comfortable with a question that says, here is 2 vectors, let's say u and v, find the angle between them, in this case 83 degrees. Comfortable with that? Right. Then the next bunch of questions start at 10. 11 is similar, so is 12. So the next bunch of questions are from 10 to 12. And they ask you, I think they phrase it like this: determine if the 2 vectors, we'll call them u and v, are perpendicular. Or if you prefer, try to orthogonal. So let's show you what one of those looks like. This is question 12. U is the vector 12, negative 8. Actually, it's 12i minus hi, but I'll write that down anyway. And v is going to be the vector negative 2i, negative 3j, and I write it like that. And I am going to do only one calculation. Since they're only interested in a yes or no answer, yes, it's perpendicular, or no, they're not, I don't need to go through all of this to find the angle. I just need to find this guy. Well, it's 12 times negative 2, add negative 8 times negative 3. Well, those two get you negative 24, and those two get you plus 24, and the answer I have here is 0. Okay, dot product equals 0. Is the answer yes, they are perpendicular, or no, they're not? What's the answer? Say again?
Yes.
And that's you finished. You can read those questions are going to be even quicker. Now, if the answer is 42, won't you say no, they're not perpendicular? And if the answer is -3, you will say no, they're not perpendicular, because all they want to know is yes, it is, or no, it's not, right? They don't need any more detail in those 3 questions. Hey, that's us halfway through, and it's only 15 minutes. So this section is going pretty quick. It's going to slow down a little bit because the further that we go, the more difficult it's going to be. Now, the next bunch of questions cover 13, 14, and 15. And these are calculations using the dot product or containing the dot product. So I'll give you an example of one. U is the vector 1, -2. V is the vector 9, 1. And W is the vector 0, 5. So we have 3 vectors. And you could be asked to do calculations using or involving a dot product. For instance, you might get U dot V take away U dot W. If I did this calculation, would the final answer be a number or would the final answer be a vector?
Number.
Number. So let's see what we get. 1 times 9, add -2 times 1. Take away, I guess I'll put a big bracket around there to be safe. 1 times 0 plus -2 times 5. Well, 1 times 9 gets me 9, take away 2. That's nothing. That's -10. So take away -10 is add 10. And so combining all these guys together, I believe the answer is 17. Or you might get a question like this. Now, it's a different kind of calculation, right? It has a dot product in it, it has some brackets, and it's got an add. So if we want to do this question, and we have to make sure that we do it in the right order. So the right order would be add these 2 vectors first, and then do the dot product second. So the vector U is this guy. Dot product, this guy plus this guy. So what's that going to get me? 9 add 0 is 9. 1 add 5 is 6. So U dot product, what you get when you add the other 2 together. This becomes 1 times 9 plus -2 times 6. That's 9 take away 12. And so in this case, the answer would be -3. Are we comfortable about calculations that involve a dot product? And here are some examples. I would say, hope you agree with me, that this is a lot simpler than quite a few things that you've done in the past. Right? There's nothing too strenuous going on here. That would be my opinion. The next group of questions are going to calculate what is called the work done. And they start, I'm trying to get the beginning one now. Basically, that's question 16 to question 20. And that'll be us pretty much finished. So, need a little bit more on the last one. These are basically applications. These are why you might want to find a dot product. So, the formula for calculating any work done, W for work done, is a dot product of 2 vectors, F and D. F is the force vector. So can you imagine that we've got a hill and there's a big block on that hill, but there's no friction. But I pull that hill or I pull that block, this block here, up a hill, and I use that force vector, right? And I pull it from here to here, and that's P and that's Q. And that there is the distance vector, or the movement vector. So all you need to be told is what vector is representing the way you're pulling it. Because right now I'm pulling it parallel to the hill, which actually is the best way to do it. But can you imagine that I wasn't so bright and I was pulling it like at an 80-degree angle? That would actually cost me a lot more work, wouldn't it? Be harder to do, right? Have you ever noticed that lifting heavy things is easier to keep them horizontal than it is to move them uphill? Right, the work done is different, right? And so D is the movement vector. Now, as long as they tell you who these two guys are, don't you just find the dot product and that's your essentially your work done. So question 16, you're using a force, and here is your force vector, 2A, and you're moving it from a point P.
What does D say? The force for D?
Say again?
What does the vector D say?
It says movement. So it's a
Thank you.
movement vector, right? So in here, question 16, then the force vector is 2A, and we're going to move it from a point 25 to another point 11, 9. So these two guys, the start and the finish, that's like my P and my Q. I need to find out what that vector is. So in this case, it would be those two guys, right? Force vector, dot product with the vector P to Q. So I'm going to find the vector PQ. It's been a little bit of time since we did this. I think the formula was something like x2 take away x1 comma y2 take away y1. I tend to do it as second guy 11 take away the first guy 2. So I go 11 take away 2 is 9. 9 take away 5 is 4. You see how I calculate that? Second guy take away first. Second guy take away first. There's the PQ. So what is the work done in using that force to move an object from this position to that position? Well, it's a dot product. And that vector is 2, 8. And this vector is 9, 4. And the dot product is 2 times 9 plus 8 times 4, which I make 18 and 32. So I get 50. And there are units that you don't need to worry about because WebAssign tells you the units. But if you're interested, the units are foot pounds, or at least in America they are. I believe if you go metric, Newton meters, I think's the units for work done. I wouldn't worry about the units. They tell you them, right? If you're not into physics. But 50. Yeah.
Sorry. During our exams, do you prefer that we write units in our answers? Because we don't usually use units throughout just the coursework.
We don't. You're right. I mean, the only time I would be pernickety, there's a good word. If it was degrees, I'd like to see the little circle.
Yeah,
right?
yeah.
And if it was radians, I'd like to see a rad. Because in that case, there is a significant difference. But you don't need to worry about being foot pounds or Newton meters or cubic thingies. It's nice if you do it, but I'm not a physics teacher.
Okay.
If I was, I'd be really pernickety about that. Isn't your chemistry professor units, units, units?
Yeah.
I'm a math guy, so I'm number. I'm more interested in the 50 and less interested in the foot pound, where maybe your physics teacher is very interested in the foot pound and maybe, well, you should be interested in the number as well. Are we comfortable with that last question? That if you want to find the work done, you find the dot product of a force vector with the movement vector. Now, this is example question 17. The force vector is 4, -6. Actually, in the question, it's 4i take away 6j, right? But I like this notation, so that's what I do. You can choose to do it or not, right? And in question 17, this force is being used to move an object 9 feet along the x-axis. So can you imagine? I think of boxes. There's a box here, and you're going from here, which I'll call 0, and you're moving it to here, which is 9 feet. And you're moving it a really stupid way, but you're pushing it downwards. I guess you're dragging it along the floor. It's almost like you're on top of it, pushing it and dragging it, right? A really weird angle, right? Because that's what it is. And we are going to find what the work done is. Well, since that is my movement vector, right? The vector we tend to call D, isn't that simply just 9, 0? Would you agree? 9, 0. So the work done is F dot product D. And so 4, -6 dot product with 9, 0. And so that's 4 times 9, add -6 times 0. And the answer we get here is 36. Are we good with that? Dot product, put all the guys together, call it good. What question was that? 17. And if you're interested, units are foot pounds. Nothing special happening in 18, 19, and 20 are just basically these kind of questions that we've done. So we are on to our last question. Yes, it is. The last one I'm going to do anyway, and that's question 21. So a lawnmower, oh, the lawnmower guy. 30 degrees going this way. He pushes it along the ground. Oh, so from there to there, from 0 to, lost the number, 200 feet. Okay. So he's cutting the grass. There's the grass. And he's pushing it this way. And what is he doing? 55 pounds. So there is his vector. That's the guy. God, I'm a great artist, right? There he goes. Pushing it down. Here's the lawnmower, 200 feet that way. I need 2 vectors. I need to know this force vector. And I need my movement vector. Now, horizontal, 200 units going that way. Are you okay with -200, 0? If he was pushing it that way, it'd be +200, 0, right? Now, this fella here is a bit of an issue. And we did have I think almost a carbon copy of this one, didn't we? So I'm going to get the components, right? These 2 numbers. And I'm going to get them by finding the X component and the Y component. Now, the X component is the magnitude of the force times the cosine of the angle. And the Y component is the magnitude of the force times the cosine of the angle. So that's going to be 55 cosine of 30 And this is going to be 55 sine of 30. And on my calculator, and I'm going to
Hey,
make it,
Professor,
yes.
you wrote it as the y component equals the
Oh, I
magnitude
got
times
that.
cosine theta.
Thank you. The minute you said it, there. Y component is this guy. And why am I writing
You still have it wrong.
that again? Being the last question, I should take my time because we get tons of time. Will someone tell me the formula for the x component?
It's the magnitude times sine theta or cosine theta.
Thank you. And actually, now I've got some space, I'll write down the calculation, which is 55 times the cosine of 30 degrees. And that ends up being to what decimal places? Oh, they want the answer to be the nearest whole number. I'll round it off a little bit. 55 times cosine of 30 is about 47.6 right now. And the y component of f is the magnitude of the vector times the sine of theta. So that's going to be 55 times the sine of 30 degrees, which better be 27.5. Let's find out if it is. 55 times the sine of 30, 27.5. And so I have a 47.6 and I have a 27.5. Now numerically, I'm fine with those numbers. But I really should be thinking about the sign of this answer. This 27.5, is my vector going up or is my vector going down? Is it my vector going down? Can you imagine the movement? It's along this way and it's down this way. You agree? So if I take that into account, do you see why both those numbers are still negative? Okay. Now, work done is force times movement vector. Negative 47.6, comma, negative 27.5, dot product with negative 200, comma, 0. So I should be able to do negative 47.6 times negative 200. And because I'm lazy, can I just write down plus 0? Because that's what you're going to get anyway. And then I can move to the calculator. And well, I know it's going to be positive. So 47.
Why is that just plus 0?
Well, this number times 0 is 0.
Oh, okay.
Right. So I'm going to get a 47.6 times a 200. And the answer I get is 9520, which is pretty good, but not actually their answer. So where do you think I lost the 6?
When you
See
rounded?
that guy? Yeah, see that guy there? He probably needed to be 47.682111 or something. And that's why I'm a little bit out. So even although they went and said the nearest whole number, and I thought, oh, well, if I do this to one decimal place, that'll be fine. But probably I should have written this down to like 3 decimal places, because that's probably where the 6 came from. Can you trust me on that? Right. And that's it. There's a couple of videos to watch, but nothing more. And we have finished everything. There is no more new stuff. So when I see you tomorrow and Friday, we will be going over practice for the final revision. Does any, oh, I got it written down here. When is the final? I deliberately didn't tell you, so you'd have to look it up. When is
Friday
our
the
final?
17th.
And when is it, time-wise?
From 10 to 1.
10 till 1, right? Now, I'll just tell you a couple of things and then we can finish off early today. You deserve a little break. There will be a special Zoom link for the final, right? So we won't be using a class one. I'll put it in Canvas where I put all sorts of stuff like that. Sometime this weekend, because I haven't written the final. I don't like to write the final until after we've done our major review. That way I can go over anything and I don't need to think, oh, I really don't want to answer that question, because that's just like question 2 in the final, and and all that carry on. So since I don't do the final, when we do revision, I feel much freer about going into anything. Where was I? Mumbling again. So you're going to be given, you already have it, a practice final in Canvas. There's going to be a special module where I'll be putting the Zoom link, the Desmos that you can use and all this stuff that you will be able to use during your final, right? Because you are allowed to use your notes, and everything else will disappear when the final comes.